So after the binomial distribution, the next distribution that we are going to see is known as the exponential distribution. See, what is an exponential distribution? In exponential distribution, we see this kind of a graph. See, this kind of a graph is seen in an exponential distribution. See, what does this graph mean? For example, let us say, where is exponential distribution used? Exponential distribution is used wherever an event takes place after a certain amount of time. Means what? One event is going to take place after each certain amount of time. For example, see, what can be a simple example for this? Simple example for this can be a manufacturing plant, right? So you have your conveyor belt. On your conveyor belt something is being manufactured, and after certain amount of time something is manufactured, right? Simple example is what? Simple example is your car. Whenever a car is being manufactured, you can say in Tata, or you can say in any company, for that Volkswagen or any company. See, a car is being manufactured on your conveyor belt. After certain amount of time, let us say after every 10 minutes a car is manufactured, right? So this is what one car is manufactured in 10 minutes. It doesn't mean that one car manufacturing takes 10 minutes, huh? A car, for manufacturing one car, it takes a very long time, but from the conveyor belt one car is brought out every 10 minutes, right? So in case of exponential distribution, what does it say? It says that the probability of getting a car out in the 10 minutes is very high, right? After 10 minutes there is probability. It is possible that it might take 11 minutes, it is possible that it might take 12 minutes, 13 minutes, right? It is also possible that one car might get manufactured in 8 minutes or in 9 minutes, but 10 is what? 10 is the average, right? So before getting it, before is also possible, getting it afterwards is also possible, but what is the most possible time for getting the car out? The most possible time for getting the car out is 10 minutes. So in case of exponential distribution, you always have a time factor. In case of exponential distribution, you always have some kind of a rate factor. Okay, so we can, right now we can take rate to be per unit time. So whenever you have a question of exponential distribution, now there is a very simple thing that you have to do. There is only one variable in case of an exponential distribution. That is what? That is the frequency. So what is frequency? See, you must know what a frequency is. We know frequency of sound, right? Whenever we want to measure the frequency of sound, what is the unit that we use to measure frequency of sound? We use hertz. And what is hertz? Hertz is 1 upon second, right? Inverse of second is hertz, right? So whenever you have an exponential distribution, you should always first of all find the frequency. Once you know the frequency, there is just one formula. Substitute the value of frequency in that formula and you will get your answer. So how is this going to work? First of all, how will you find out the frequency? I always remember, frequency is going to be in something like this unit. It is going to be 1 divided by some form of time. This time can be what? This time can be seconds, minutes, hours, days, months, years, anything. But the unit is going to be 1 divided by some unit of time. So that is going to be your frequency. For example, just to give you an example, let us look at this question. In a car manufacturing company, one car comes off the conveyor belt every 8 minutes, right? So what is happening in that company? A car is coming off the belt every how many minutes? 8 minutes. So one car every 8 minutes. So what do we have to find? We have to find out the frequency. What is the unit of frequency? What did I just tell you? The unit of frequency is something 1 divided by some form of time. So in our case, what is time? In our case, the time is given in minutes, right? So our frequency is going to be 1 divided by minute, right? So how many cars are, if one car takes 8 minutes to manufacture, right? One car took how many minutes to manufacture? 8 minutes. So how many cars are going to be manufactured in 1 minute? 1 upon 8 car, right? One car takes 8 minutes to manufacture. So in 1 minute, how much of a car will be manufactured? Only 1/8 of a car will be manufactured now. So what is going to be our frequency? Our frequency is going to be 1 by 8 car per minute. This is going to be our frequency. I will just give you another example. Let us say that you are working in some kind of a fan manufacturing company. Okay, you are working in a fan manufacturing company, and in that fan manufacturing company, 5 fans are manufactured every minute. 5 fans are manufactured every minute, right? So in this case, what is going to be your frequency? Your frequency is going to be 5 fans per minute. Why? Because how many fans are manufactured in every minute? 5 fans are being manufactured in every minute. So it should be what? It should be something per time. Here it is cars per time. Here it is fans per time, right? So this is going to be your frequency. Now for frequency, what is the symbol we use? We use lambda. So lambda is going to be 1 by 8. So this is our frequency. Now we know the frequency. So if we know the frequency, we can use it to find the probability. I just showed you this graph right now. This graph is the graph for exponential distribution, right? So how do we use this graph? If we want to find, let us say we want to find here, let us say I am just taking a random example right now. Here, let us say it is 2 minutes. If we want to find out what is the probability of a car manufacturing within the first 2 minutes, okay, see, there is this car that has to be manufactured. Okay, there is going to be this car that has to be manufactured. What they have told us that for one car to manufacture, means to come off the conveyor belt, it takes generally 8 minutes. On an average, it takes 8 minutes. But it can happen that the car may get manufactured early. It may happen that the car may get manufactured late. It is possible that it might take 10 minutes. It is possible that it might take 6 minutes, right? So what is the probability that the car will get manufactured in 2 minutes? If we want to find out that the probability of car getting manufactured in 2 minutes, we are going to have to calculate this area, right? If we want to find out what is the probability of the car getting manufactured in 4 minutes, okay, what is the probability of the car getting manufactured in 4 minutes? Then we will have to find out this area where this is 4. But if we want to find out what is the probability of the car getting manufactured after 4 minutes, this is what? This is in 4 minutes, or this is before 4 minutes, right? The car getting manufactured within 4 minutes. Then we are going to use this graph. But what is the probability of the car getting manufactured after 4 minutes? Then if this is 4 minutes, if this is before 4 minutes, this is going to be after 4 minutes, no? Right? So this is before, this is after. If we want to find out before, we have to find out the area from here. Right now, before 4 minutes means what? Within 0 to 4 minutes now. And after 4 minutes, what means after 4 minutes? Now, here there will be 5, here there will be 6, here there will be 7, and so on. So it depends. If you want to find out the before time, you have to find out the area before the time. If you want to find after it, then we have to find out the area after the time. Right? So in our case, what is the question that they have asked us? They have asked us, first I will solve question number 2, B part, then I will go to question number A part. What is the probability of car coming out of the conveyor belt after 4 minutes? So they are asking us to find out the probability of the car getting manufactured after 4 minutes. So our lambda is what? Our lambda is 1 by 8, right? Cars per minute. Then they have told us what? That the car getting what is the probability of the car getting manufactured after 4 minutes? So if this is your 4 minutes, we have to find out this area. So how do we find out this area? What is the formula? If you want to find out the area after a certain amount of time, okay, probability of some x greater than 4. Okay, rather than 4, I will write over here first px greater than x. Okay, what is the formula in case of exponential distribution? For exponential distribution, what is the formula? Formula is e raised to minus lambda x. This is the formula that you have to remember for exponential distribution. Probability of x greater than x is equal to what? E raised to minus lambda x. It is as simple as this, right? So we can substitute the value in this. So what is going to be probability of x greater than 4? We are going to put e raised to minus lambda is what? 1 by 8 into 4. So it is going to be what? E raised to minus 4 by 8. So it is going to be e raised to minus half. So we can put this in our calculator. So if we put this in our calculator, e raised to minus half, we get the probability as 0.564. So what is the probability of the car getting manufactured in the 4 minutes? The probability of car getting manufactured in 4 minutes is after 4 minutes. What is the probability of the car getting manufactured after 4 minutes? The probability of car getting manufactured after 4 minutes is 0.564. Right? Similarly, if we look at part A, what are they telling us? What is the probability of a car coming off the conveyor belt between the next 2 and 4 minutes? So when should the car come? Between 2 and 4 minutes, right? So if we look at the graph, when should the car come out? The car should come out between 2 and 4 minutes, right? So this should be the area. It should come out between 2 and 4 minutes. So how can we calculate? See, to calculate this, we can do two calculations. First, what are we going to do? First, we are going to calculate the area from 2 minute onwards, right? We are going to calculate this full area from 2 minute onwards. And then what we are going to do, from this, we will subtract the area of 4 minute onwards. Right? We have this total area, we have this red color area, and from this red color area, what are we going to subtract? We are going to subtract this blue color area. So if we subtract this blue color area from this red color area, what is the area that we are going to be left with? The area that we are going to be left with is going to be this green color area, right? This is the area that we will be left with, which is the area that we are interested in. So to find out this area, what we have to do? We have to find out area after 2 minutes. We have to find out area after 4 minutes and subtract this 4-minute area from this 2-minute area. Then we will get the area between 2 and 4 minutes, right? That is the probability of the car being manufactured in between 2 and 4 minutes. So what we have to do? We have to find out probability of x greater than 2, that is the car is manufactured after 2 minutes. From that we have to subtract the probability of x greater than 4, that is we have to remove the probability of x getting manufactured after 4 minutes. That is why we will be left with probability of x between 2 and 4, right? X will be between 2 and 4. So what is probability of x greater than 2? E raised to minus lambda into 2. What is the probability of x greater than 4? E raised to minus lambda into 4. So it is e raised to minus 2 by 8 minus e raised to minus 4 by 8. So it is e raised to minus 1 by 4 minus e raised to minus half. So I will just put this in the calculator. E raised to minus 0.25 minus e raised to minus 0.5. Answer is coming out 0.1723, right? So the probability of a car getting manufactured in the in 2 to 4 minutes is what? 0.1723, which can be 17.23 percentage. Right? So this is the probability of the car getting manufactured within 2 to 4 minutes. And what is the probability of a car getting manufactured after 4 minutes? Probability of car getting manufactured after 4 minutes is 0.564 or 56.4%. So this was your question number 7, in which we have seen what? We have seen exponential distribution. This is an example of exponential distribution.